Hi everyone. This is going to be our first video on the subject of trigonometry. Trigonometry actually comes from two Greek words or roots. Trigon, which means triangle, three sides, and the meter part of it means measure. So we're talking about the measurement of triangles in trigonometry, specifically the relationships of angles and the sides in a triangle. We're going to find that it has a great deal more application than just the measurement of triangles, but that's where it comes from, and that's where we'll start. What we're going to do is we're going to start our discussion with trigonometry by looking at probably the simplest of the triangles in terms of the mathematical relationships between the sides, and that's a right triangle. So let's take a look quickly at what we know about right triangles from geometry. We know that a right triangle has one right angle, one 90-degree angle, and it has two acute angles, those that are less than 90 degrees. And we'll call them A and B for now. And we know that the sum of the angles in a triangle is 180 degrees. So if one of our angles is already 90, that means that my A and my B have to add up to 90 degrees, meaning that my two acute angles, let me go ahead and circle them, my two acute angles in a right triangle are complementary. They add up to 90 degrees. We also know that a right triangle has three sides. The two sides that make up the right angle, we'll label them little a and little b here, are called the legs of the right triangle. Those are the two sides that make up the right angle, and the longer third side, which is called the hypotenuse. Probably the most famous relationship we get from a right triangle is this one. You're all familiar with it, the Pythagorean theorem, that says if we add the squares of the lengths of the two legs, we get the square of the hypotenuse. Very, very important relationship, particularly later on in trigonometry. You also need to understand the terms opposite and adjacent. Okay? Opposite and adjacent. So let's take a look at the word opposite first. The term opposite refers to the side, or a side, that is not part of the angle we're referring to. So if I were to look at angle A, for example, let me take a look at angle A here. Angle A is composed of two sides, B and C. So the side that is not part of that angle is this side over here, angle A. So this is the opposite side for angle A. Okay? It's the leg A. If we take a look at if we look at angle B, the angle B is made up of sides A and C. So the side that is not part of the angle is B. Okay? And it sometimes helps just to think of the word opposite meaning across the triangles, because that's where you have to go to find that side. The other word that's important is the word adjacent. The word adjacent means that it is part of the angle. And I will tell you that we typically use the term adjacent to refer to a leg. We don't usually use the word adjacent to refer to the hypotenuse. Sometimes you'll hear the hypotenuse described as the side that is across from the 90-degree angle. It's a good definition for the hypotenuse. But for the adjacent, we're usually talking about the legs. So if we take a look at angle A, let's talk about angle A again. Again, I'll do it in blue. This leg right here, angle B, is my adjacent side, since it is part of angle A. And for angle B, the leg that is part of the angle is side A. That's your adjacent side. Okay? I probably should have written in opposite over here, just so we know what we were talking about. Okay? You can also think of the word adjacent in its normal everyday English usage, which means next to. And if you look at it, it kind of makes sense. This side, side B, is next to angle A. Side A is next to angle B. The reason this is all important is because we use these terms opposite and adjacent to define are trigonometric functions, are functions in trigonometry, and there are 6 of them altogether. I've drawn a second right triangle here for us to use. Let me go ahead and label some sides here. Let's use some different labels here. Let's call this X and call this Y, strictly because we're used to seeing the X as the horizontal and Y as the vertical. And I'll call this, oh, I don't know. Let's just stick with C. How's that? And we're going to use a Greek letter here to indicate the angle that we're going to look at. That's the Greek letter theta. Greek letter theta. You'll find that in math, when we start using variables for angles, we tend to use Greek letters like theta, that's T-H-E-T-A, or sometimes you'll see alpha or beta or a bunch of different kinds of Greek letters. But theta is certainly the most common. It's the one you'll see me use the most. So let's talk about our 6 trigonometric functions. There are 6 altogether. They are sine, cosine, and tangent. Those are the main 3. Those are the ones that you may have heard of before. But there are actually 3 more. Cosecant, secant, and cotangent. We abbreviate these functions with the first 3 letters, at least in 5 of them. SIN for sine, COS for cosine, TAN for tangent, SEC for secant, and COT for cotangent. We can't use COS for cosecant because we already used it for cosine, so we use CSC as the abbreviation. So let's talk about the definitions. All of these trig functions are ratios of side lengths. They are ratios. Trigonometric functions are ratios. Okay? So these 6 definitions here are all defined or all indicated by the ratio of side lengths. So let's talk about angle theta, or any angle for that matter. The sine of an angle is equal to the opposite side, the length of the opposite side, over the length of the hypotenuse. The cosine of any angle is equal to the length of the adjacent side over the hypotenuse. And remember, all we're talking about right now are right triangles. We can use these trig functions for non-right triangles, but we won't get to that for a bit. Okay? And my last trig function of the standard ones is tangent. That's opposite over adjacent. Okay? So let's take a look at what that means in terms of angle theta. For angle theta, side Y, which is across the triangle from it, which is not part of the angle, is our opposite side. And side X is our adjacent side. Okay, so we should be able to write, and we know, of course, that C is our hypotenuse. So we should be able to write the 3 trig functions using those variables. Our opposite side is side Y over my hypotenuse. We'll call it C. My adjacent side is X over the hypotenuse C. And my opposite is Y over my adjacent X. The other 3 trig functions are actually just reciprocals of the first 3. Cosecant is the reciprocal of sine. Which means it's the hypotenuse over the opposite, which in this case would be C over Y. For cosine, the reciprocal is secant. 1 over cosine, the reciprocal. So that means it's hypotenuse over adjacent, which would be C over X. And the reciprocal of tangent is cotangent, 1 over tan, which would be adjacent over opposite, or X over Y. So there's the definitions of our 6 trig functions. Just for the heck of it, let's do an actual problem with actual numbers just so we see how these ratios work out. So I'm going to draw one more right triangle, and we're going to define these six trig functions for this right triangle. I draw another one here real quick. And we'll use the standard 3, 4, 5 right triangle. 3, 4, 5 right triangle. Again, here is our right angle. Draw that in. Okay, let's again look at this Greek letter. We'll look at this angle. Oops, I need to turn off my straight line here. There we go. So now we're looking at the Greek letter. Here's my angle, theta. And let's say that this is a 3, 4, 5 right triangle. Okay? So the sine of my angle theta is going to be the length of my opposite side, which is 3, over the hypotenuse, which is 5. Which means my cosecant, which is the reciprocal, is going to be my hypotenuse over my opposite side. My cosine is adjacent over hypotenuse, so my secant is going to be my hypotenuse over the adjacent. And then tangent is going to be opposite over adjacent, so cotan is going to be adjacent over opposite. So that's how we define the 6 trig functions using the ratios of sides in a right triangle. Thanks.